The email password authentication is a two-step process in which the login service is responsible for first verifying that the email password pair matches an existing record in the database, and second, generating a temporary access token that will be used by the client to later on access or update restricted resources on the application. So in this lesson, we will implement a first version of the login service using a fake function that will help us simulate a database operation. So let's start by installing the bcrypt and JSON Web Token packages, and let's create a new directory named services, and within it, a file named login. Since the data access layer is not implemented yet, within the login file, we're going to use a fake function named getUserFake that will simulate a read operation just as if we were fetching a record from an actual database instance. So let's create the asynchronous getUserFake function that takes as argument an email address. Within it, let's create a user object that will act as a database record and that contains an ID, an email, and a password hash generated using the bcrypt hash function. Finally, let's return a resolved promise that either contains the user data object if the provided email matches the hard-coded email value or a null value otherwise. Now that our fake function is ready, let's move on to the login service itself. This module will export an asynchronous function that takes as argument the data parsed by the router layer, which should contain the email address and the password provided by the user, and a secret string contained in the environment object that will be used by the JSON Web Token package to generate an access token. This function will then call the getUserFake function using the provided email address to retrieve the user record and return a null value in case the requested user doesn't exist. Then call the compare function of the bcrypt package to verify that the provided password matches the hash value contained in the user object returned by the call to the getUser function. Then generate a new access token using the sign method of the JSON Web Token package that will contain the ID of the user in its payload, use the secret string to encode it, and add an expiration date of 1 hour to it, which will force the client to re-authenticate past this period of time. Now, in order for the login service to have access to the data object provided by the router layer and the secret string contained in the configuration, we need to move one step back to add the secret to the configuration and make some changes to the controller responsible for invoking the service. So let's open up our development configuration file and create a new variable named gwtsecret, whose value will be used to sign the JSON Web Token. Once we've done that, we can add a new GWT property to the object returned by the environment loader module in order to reflect the changes we just made in the configuration file. Now, in order for the login service to have access to the secret variable contained in the environment object, we have to first inject this object into the login controller so that in turn it can forward it to the login service when invoking it. However, the problem is that we're not allowed to directly modify the signature of the controller since each of its parameters have a special meaning and are used in a specific way by the Express framework. That being said, to solve this issue, we can define an intermediary function in charge of gathering all the dependencies needed by the underlying layers of the application and returning the request listener function, which would translate to the following piece of code. From here, we're going to update the controller itself by setting up a try-catch block that will intercept any potential error thrown within the login service and respond with an HTTP 500, which means that the server encountered an unexpected condition preventing it from fulfilling the request. Once we've done that, we're going to import and invoke the login service using the parsed data present in the request body and the secret string present in the environment. And we're going to define an if-else structure that will allow the controller to either respond with an HTTP 200 containing the access token sent back by the login service, or an HTTP 401 otherwise. And of course, let's not forget to convert the controller into an asynchronous function since we're awaiting for the login service to respond. Finally, we're going to move another step back to update the declaration of the login controller within the server loader module in order to initialize it with the environment object. Now that we are done with the coding phase, let's verify that our application responds with an HTTP 200 containing an access token by sending a request containing the email password pair defined in the getUserFake function, and that it responds with an HTTP 401 otherwise.